All right, so in our previous unit, we looked at integers in different bases, and we're going to formalize that now. So a positive integer in base b, and I should have been more explicit here, and we should have n base b, is going to be an n plus 1 digit number. So notice we have our digits sub n all the way down to digit 0. And each of these digits are going to be smaller than the base value, because as soon as we get a number that's the base value or bigger, we go up to the next digit. And what each of these is representing is if we convert into base 10, so this is a typo, the value of n base 10, so that's our traditional number system that we think of. So this is going to be n base 10. So the way that we calculate it is we take this digit and we multiply it by our base number raised to this power. So for example, if we have in base 10 the number 217, what this really means is that we have two 100s plus one 10 plus 7. So what we end up with then is this is 2 times 10 squared plus 1 times 10 plus 7 times 10 to the 0. And so this is what we are writing down here. All right, so the next thing we want to think about is hexadecimal. So hexadecimal is base 16, but of course we only have the numbers 0 to 9. So with hexadecimal, to get the next values up to 16, we add the letters A to F. So I've defined here, A in base 16 is the same as 10. In base 10, B base 16 is the same as 11. Base 10, so on and so forth. This course, we only go up to hexadecimal. We only go up to base 16. All right, so convert the following to base 10. We have 35,072 base 8. Well, this is going to be the same as 3 times 8, so we want to count how many powers we have. We have 0, 1, 2, 3, 4, so 0 times 8 to the 4, sorry, 3 times 8 to the 4, plus 5 times 8 cubed, plus 0 times 8 squared, plus 7 times 8, plus 2. If we calculate this all out, then we're going to find that we have this value here. I've calculated it out already, 14,906. And that is in base 10. So if we think about another way to calculate this, we can use something similar to synthetic division notation. So I've got 4, 2, 1, 1. And the reason that this works is I bring down the 4, and now I'm going to multiply by 5. So that's going to give me 20. Add the 2, I get 22. So now I'm multiplying by 5, which really means that my 4 is now getting multiplied by 5 twice. And then it'll get multiplied by 5 a third time, and then multiplied by 5 a fourth time. And so 22 times 5 is going to give me 110. So I have 111. 555 is going to give me 556. That seems like too small of a number. Let's go check. 556. All right. So either way, we can work it out using this method or using a similar to synthetic division model. And here, I think I said that my 4 was going to get multiplied by 5 4 times. Of course, it only gets multiplied 3 times. So first time, second time, third time, because this value doesn't get multiplied by 5 again, but it ends up being the same. We had 4 times 5 to the third, plus 2 times 5 squared, plus 1 times 5, plus that last one, also ended up giving us our 556 in base 10. So I'm going to leave you to do C and D on your own, and again, ask me if you have questions about this in class.